Hi, welcome to another class. So integrating a constant. So this class will be a bit of an explainer around the reason why when we integrate a constant, we obtain something like this. Where did the x come from? So as we all know, if you want to integrate a function, you simply increase the index of the function by 1, then you divide by the new index, and leave the coefficient the way it is. Then you can add an arbitrary constant. For example, if you have a function such as this, f of x equal to x raised to the power n. To integrate this function now, integrating x raised to the power n dx, you obtain x, you increase this index by 1, then you divide by this new index. Now, or any coefficient you have here, whatever coefficient it is, in this case it is 1, you leave it the way it is, then you can add a constant of an arbitrary value. So these are the steps you take to obtain the integral of a function. So when you do that in this case, where will this x come from? So let's get into the class and explain this. Welcome again. So to try to explain why we have this, we're going to assume that this integral k dx can be written as integral k x raised to the power 0 dx. Now we know that x raised to the power 0 is equal to 1. So 1 times k is still k. So this is still the same thing with what we have here. So this will now come down to be, we'll follow this integration process. We'll have k x raised to the power 0 plus 1, then we'll divide by 0 plus 1, and we can add our c. Now this is going to give us k x, because this will now become 1 over 1 plus c. So we'll now have kx plus c. So this is the reason why we have this. Now if we have something like, if we want to find, for example, if we have a function such as, let's say 2x plus 2, we want to integrate this function, we're going to have 2x squared, increase the index of the function by 1, over 2 plus, this is a constant, which is this 2x plus c. So this is going to give us, of course this cancel out this, so we'll have x squared plus 2x plus c. I obtained a full quadratic expression. Now this makes sense, because if we want to find the derivative of this function using this formula, we're going to get this, will have 2x 2 minus 1 plus 2x 1 minus 1 plus, of course this is going to give us complete 0 when we differentiate, and this will give us 2x, 2 minus 1 is 1, so we'll have 1 plus 2x, we'll have 0, so this is going to give us 1 plus 0. So come back to what we have before, 2. So this is what we have. So there you have it. Keep solving problems, learn from them. Until next time, bye bye.